are from Welltech Dr. R R and SR Technical University, and our project title is Design and Structural Analysis of Multi-Leg Landing Gear, and our project members are R. Balaji and H. Saddam Hussain, and our internal guide is Dr. Bhubadi M.Tech. And our objective of the project is to study, design and structural analysis the multi-leg landing gear using CAX technologies with the help of software such as ANSYS and CATIA B5. And the abstract of this project is it could be used to land in any kind of surfaces. Hence, replacing the conventional landing gear with the multi-leg landing gear, the aircraft could land at any surfaces at the time of emergency landing. This idea can be implemented on both commercial and military aircrafts. The books we are taken for the literature survey are Aircraft Landing Gear Design and Development, White Paper Infosys by Divakar VN and Ravikumar GV. The keywords which are taken from these books are stress and fatigue analysis, reliability and maintainability analysis, types of landing gear systems, and the CAX technologies. The another book was Design and Analysis of Main Landing Gear Structure of Air Transport Aircraft and Fatigue Life Estimation for the Critical Leg by PK Ravikumar R. The keywords which are taken from these books are calculations of dimensions, find element analysis of landing gear, and analysis of lug. The other book was Design and Structural Analysis of Weight Optimized Main Landing Gear for UAV Under Impact Loading by Reyes Fida Swati. Keywords which are taken from these books are impulsive reaction, CAD and CFD analysis, material properties and geometric parameters. The another book was Design and Analysis of Landing Gear Lug Attachment in an Airframe by Prasad Kabade and Ravi. Keywords are stress concentration, fatigue life of lug, and a minus tool. It is the rough design of the multi-leg landing gear which are created by the hand. It is a conceptual design. This is the 2D design we have developed in the AutoCAD. The dimensions of the landing gear are not available in any of the websites, so we have taken the dimensions from the Airport Maintenance Authority landing gear. These are the three views of the Boeing 777F type aircraft. From the drafting method, we can find the dimensions of the aircraft. This is the front view data gained from the 3D diagram. From this gained data, we can find the height and length of the landing gear. From this diagram, we calculate the total length of the landing gear. The distance between the two wheels is 2.8 feet and the width of the tire is 1.5 feet. For the two tires, the gap between is 3 feet. This is the top view data gained from the 3D diagram. From the data, we can calculate the total base length of the landing gear is 13 feet and the distance between the wheels is 0.83 feet. The diameter of the single wheel is 2.62 feet. The force distribution of the landing gear. From this, from the Boeing website, we have taken the maximum impact load as 144,241 kg and the velocity approach is as 136 gas and then thrust is 77,000 lb. The percentage of load supplied on the landing gear. The load acting on the landing gear is 14% and on the main landing gear is 86%. For the single main landing gear is 43%. The calculation for finding gravitational force. F. The maximum load is 144,242 kg and then the single main landing gear weight is 62024.06 kg. The nose landing gear hanging weight is 20193.88 kg. The components of the multi-leg landing gear are anchor arm, upper OLS stud arm, mounts, stud connector, shock absorbers, lower OLS stud arm, base carriers, elastic dampers, elbow rod and wheels. This is the anchor arm which we are developed. These are the dimensions of the anchor arm. This This is a 3D model of an anchor arm which we have developed in the SolidWorks. This is the shock absorber. The height of the shock absorber is 4.5 feet and the spring diameter is 0.8 feet. Number of turns is 12. The function of the shock absorber is to capture the shock from the landing gear at the time of landing. This is the base carrier. The function of the base carrier is to hold the shock absorbers and lower retractional rods to the wheels. The diameter of the base carrier is mentioned here. This is the top and the side view of the base carrier. This is the elbow rod. The function of the elbow rod is to fix the wheels. These are the landing gear wheels which we have developed. The dimensions of the landing gear are mentioned here. This is the 3D assembled view of the multi-leg landing gear. All the dimensions are clearly mentioned here. This is the side view of the assembled multi-leg landing gear. This is the top and bottom view of multi-leg landing gear. Side views. This is the sectional view of the multi-leg landing gear which we have taken from the ANSYS. This is the top and side view of the multi-leg landing gear. The materials which we are selected for the is titanium alloys. We applied titanium material property for base plate only. For the rest of the materials, for rest of the components, we applied chrome stainless steel as material property. The force we have applied is 304 Newton, which we are applied on the top of the multi-leg landing gear. This is the structural deformation we get from the analysis. There is no structural deformation occurs. A little deformation will occur on the top of the multi-leg landing gear. This is the maximum principal elastic strain. This is the result of maximum principal stress. This is the strain energy which we have got from the ANSYS. This is the maximum shear stress results. This is the maximum shear elastic strain results. Results and discussion. In this multi-leg landing gear, we applied a vertical static load and the safe load was calculated as 304 kN. No structural deformation will be formed in this structure due to shock absorbing technique, which is achieved by placing the mechanical shock absorber on the four types of base carrier to arrest the landing vibration. We found the maximum principal elastic strain, maximum principal stress, strain energy, maximum shear stress results from this static structural analysis. Conclusion. The landing gear space structure highly has statically determinate structure. Its reactions, forces acting on each member are determined by using simple numerical approach. From the dimensions obtained, analysis the landing gear structure is done. The safe load of multi-leg landing gear is 304 kN, which is obtained from the structural analysis. This type of landing gear can be applied in both small and large commercial aircrafts, as the results found has ensured that this landing gear will work efficiently on design condition. Thank you.